Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Okay, let's proceed to some common names of alcohol. So these are actually very basic only. Okay, so common names of some alcohol. So you have your 2-propanol. So this is actually 2-propanol. You have one, two, three. So that is 2-propanol, which is actually also called as isopropyl alcohol. Okay, the one that is actually used for disinfectant also that we can buy on the pharmacy and also in the market. Okay, so we have also 1,2 ethanidiol or ethanediol, which is actually called an ethylene glycol. This is actually used as antifreeze on cars. Okay, especially those country that actually very cold because of the in winter or this there is a snow there, so they actually put ethylene glycol in the water tank in the cars so that it will be not it will not be frozen because this is actually used as an antifreeze. Okay, then you have your ethanol. This is actually the same as your isopropyl alcohol, which is actually used also for disinfectant. This actually the common name is ethyl alcohol, or what is also called as grain alcohol, because this is actually an alcohol that is actually produced in the fermentation. Okay, for some carbohydrates. Okay, that is that is formed by fermentation, and therefore this is actually the alcohol that is present in your beverages. Okay, and in wines. There are also some medically important alcohol. You have your methanol or methyl alcohol. This is actually colorless and odorless liquid that is used as solvent and starting material for the synthesis of formaldehyde. So your methanol or formaldehyde is actually formalin. So as you can see here in the picture, formalin is used to preserve tissues and organs, and it is also used in embalming. Okay, so in embalming dead bodies, they actually use formalin. Okay, so your methyl alcohol is the starting material for the production of formalin or methanol or formaldehyde. It is colorless and odorless, and it is actually very toxic and it can cause blindness and even death when ingested. Okay, and it is also used as fuel in racing cars. Ethanol is also colorless and odorless liquid, and it is the alcohol that is present in alcoholic beverages. Okay, it is used as solvent and starting materials for other organic compounds or other chemicals, and it is made from fermentation of carbohydrates or sugars and starches. Okay, that's why if we are going to produce some wines, okay, so there is a fermentation process there so that we can produce an ethanol. Okay, so your wines are actually produced. Okay, so if you have your sugar, like for example grapes contain sugars. Okay, so if you're going to ferment this using some enzyme that is actually found, usually we use yeast that the one that is used in baking. Okay, we usually use that to ferment sugars to produce ethanol, and also for wine making, we actually use yeast. Okay, so there's an enzyme there, or that fungi is actually that is Saccharomyces cerevisiae. That is the scientific name for that enzyme that is present there. Will take up the sugar and also will convert that sugar. The byproduct would now be your ethyl alcohol and carbon dioxide. Okay, so in wines, you would expect that the alcohol concentration would be probably around 10 to 12% only. That would be the maximum for wine, because during the fermentation, the enzyme or the fungi that is capable of converting the sugar into ethanol would also be intoxicated by the presence of the ethyl alcohol. So that means the fungi there will also die from time to time because of the presence of alcohol. That's why the alcohol production will be limited if you use yeast, or if you use a microorganism just like a fungi to convert your sugar into ethyl alcohol. However, if you are going to produce a strong concentration of your ethyl alcohol like rums, okay, like whiskeys or other strong concentration of alcohol in beverages, okay, you can distill the process so that you can have more or less a concentrated alcohol on that. Okay. However, those that are contains an absolute alcohol or 100% alcohol, it's actually regulated by the government. Okay, so we cannot purchase right away uh, on that bottle of alcohol that those contains absolute alcohol. Okay, we cannot purchase that right away because these are actually regulated by the government. So you have also 2-propanol or isopropyl alcohol. Okay, so it is used as it is also called as rubbing alcohol, and it is used as disinfectant. Okay, so you have your 1,2-ethanidiol or ethylene glycol. This is used as automobile antifreeze. So that's what I have said earlier. So it lowers the freezing point and raises the boiling point of water. Then you have also your glycerol. Okay, this is also called as 1,2,3-propanitriol or propantriol. It is also called as glycerol. Okay, this is viscous, sweet tasting, and non-toxic liquid. That's why it is very soluble in water because of the presence of your OH, and it can be used in cosmetics, pharmaceuticals, and also as lubricants. Okay, glycerol is also obtained by the byproduct of hydrolysis of fats. So we will discuss that when we go to fats in biochemistry about fats. So classification of alcohols. There are actually 3 classification of alcohols. You have your primary, secondary, and tertiary alcohol. Okay? And also you have also 4 is the methyl alcohol, which is actually understandable. Okay, so your methyl alcohol, it has your carbon is actually attached to the OH and its surrounding is only hydrogen. Okay, however, if you have your primary alcohol, you have your carbon attached to the OH. If this is a primary carbon, remember the one that I discussed on alkanes about alkyl, you have your primary carbon, secondary carbon, tertiary carbon. Okay, so if this carbon is a primary carbon, then that OH attached to that primary carbon is what we call a primary alcohol. Okay? How do you distinguish a primary carbon? Okay? If this carbon only attached to one R, okay, so if there is another carbon there, okay, so then this carbon is what we call the primary carbon. And therefore, this OH attached to that primary carbon is what we call a primary alcohol. Okay? How about your secondary alcohol? If your OH is attached to the secondary alcohol, then that OH is a secondary alcohol. So how do you distinguish a secondary carbon? If there are 2 R's attached to that carbon, or there are 2 carbon attached to that carbon, then that carbon is a secondary alcohol. No, a secondary carbon, I mean. And the OH attached to that secondary carbon is a secondary alcohol. Okay? How about your tertiary alcohol? Now, if you have your carbon, which is actually a tertiary carbon, why is it a tertiary carbon? Because there are already 2R attached to that 3 R's attached to that carbon, or there are 3 carbon attached to that carbon, then that carbon is a tertiary alcohol, and a tertiary carbon, and therefore that OH there attached to that tertiary carbon is a tertiary alcohol. Okay, so to understand fully about that classification of alcohols, I have here some examples. Okay, so determine whether the alcohol is a primary, a secondary, a tertiary, or a phenol. Okay, so like for example, letter A. So you have your carbon here. Okay, remember this? Okay, that structure there. So you would expect that that structure would be just like this one. Okay, so you have your OH. Okay, you have your hydrogen. Okay, and that hydrogen. And the remaining would now be an R group. Okay, that remaining there is an R group or a carbon something. Okay, you can replace that as an R and so on and so forth. So therefore, this carbon, is it a primary or secondary? This carbon here. This is a primary carbon. Correct. That is a primary carbon because that carbon only attached to one carbon only or one R. Okay. So therefore, if this is a primary carbon, then this alcohol is a primary alcohol. So letter A should be primary. Okay. How about letter B? So have your carbon here. Is this a primary or secondary? So this carbon is attached with another C there and also another C there. So there are two carbons attached to that carbon. Then therefore that carbon is a secondary carbon. So therefore this alcohol would now be a secondary alcohol. Very good. That is a secondary alcohol. How about letter C? You have a carbon there. Okay, that is a carbon. Attached to it is an OH. So you have your also CH3. So this carbon is attached with the CH3. Then you have also another carbon there and another carbon here. So how many carbons attached to that C? 3 carbons. So therefore this is a tertiary carbon. Then therefore that alcohol is a tertiary alcohol. Okay. How about letter D? You have a benzene and an OH. What is this compound? This is a phenol. That is a phenol. Diba? I told you that phenol is when an R is an aryl attached to the OH, then that is a phenol. A benzene with an OH or an aryl with an OH, that is a phenol. Okay, letter A. You have your carbon. There is also another carbon there and that carbon there. Okay, so this carbon is a primary, secondary, or tertiary? This is a secondary carbon. Okay, that is a secondary carbon because there are two carbons attached to that carbon. So therefore, this alcohol would now be a secondary alcohol. Very good. Okay, okay, let's move on to reactions of alcohol. Okay, so first is the preparation of alcohol. So we have discussed about how did we prepare alcohol. In alkenes, it's actually hydration. Remember the Markovnikov's rule? Okay, remember that? Your hydration of alkenes will give you an alcohol. Okay, so you have your alkene plus your HOH or water with the presence of your acid catalyst. So it can produce an alcohol. And remember, if this is only for symmetrical alkene. For symmetrical alkene, you can have a one possible product for that. But for unsymmetrical alkene, you have two possible products, a major product and a minor product. Okay? A major product, we should follow the Markovnikov's rule, while your minor product is an anti-Markovnikov. Okay? For example, cyclohexene plus water, then you have your acid catalyst. So this is actually symmetrical alkene because you have only one H for both of this carbon here. It actually contains one H. Okay, so both of these are, this carbon there contains one H. So therefore, this is actually a symmetrical alkene, cycloalkene. Okay, so therefore, you have only one product, which is actually a cyclohexanol. Okay, so you already knew how to do that. Okay, when we get back to the reactions of alkenes. Okay, you already know how that reactions happen. Okay, so you can check that if you have some confusion also on this reaction. Okay, you can also check. You can go back to that video. Okay, about reactions of alkenes. Okay, now let's move on to the reduction of aldehydes and ketones using sodium borohydride. So this is actually preparation for alcohol. Okay, reduction of aldehydes and ketones using sodium borohydride, lithium aluminum hydride, or hydride nucleophile. Okay, so reduction of aldehydes and ketones can actually form an alcohol. Okay, using this this hydrides. Okay, these hydrides are actually nucleophiles. Okay, they have hydride nucleophiles on its structure, and therefore it can actually reduce your aldehydes. Okay, to form an your aldehydes and ketones to form an alcohol. Okay, your sodium borohydride is NaBH4. You have your sodium plus your BH4, that is sodium borohydride. Your lithium aluminum hydride is your lithium AlH4, that is your lithium aluminum hydride. And this is actually hydride nucleophile. So this hydride nucleophile is actually present on both of your sodium borohydride and lithium aluminum hydride. Okay, so you should take note of this, ha? Reduction of your aldehyde will form a primary alcohol. Okay? What is it? Reduction of aldehyde will form a primary alcohol. Okay. While reduction of a ketone will form a secondary alcohol. Okay, remember that. Aldehyde, primary alcohol. Ketone, secondary alcohol. Okay? So remember the structure for an aldehyde, that is RC double bond OH. While for ketone, that is C double bond O. Then there are two R's attached to that carbon. Okay? So that becomes what now? Okay? So this carbon here is actually partially positive. Then if you have your hydride there, okay, that is hydride. So therefore, this will attack your carbon. Okay, so that hydride will be there. Notice that would be your hydride, and this ring will actually open. Okay, that will open, and if you have another source of your hydronium ion, which is actually H plus, so this reaction is actually accompanied by any proton donating there. It could be water or a solvent, which is actually an alcohol, and this will actually attach to, because you have your lone pairs there, this becomes negative, and that will attack your hydrogen to form an alcohol. Okay, so that should be the same also with this one. This is partially positive. Your carbon there is partially positive, while your oxygen is also partially negative. Okay, your hydride is a negative, then that carbon will attack that. No, this hydride will attack that carbon. Okay, then to form this bond there. Okay, and this double bond will be opened, forming your oxide, which is actually negative. And if you have another proton, okay, then that oxygen negative will attack that proton to form an OH. So that is the basic concept. Okay, but remember, your aldehyde will we reduce that will form a primary alcohol. A ketone, when we reduce the ketone, we will have a secondary alcohol. Okay? So this one. Okay. You have your benzaldehyde. Okay. Then you have your sodium borohydride, which is our source for the hydride nucleophile. Okay. Then you have your carbonyl. You have your partially positive carbonyl, and this is partially negative oxygen. Okay. So therefore, this hydride will attack that carbon, forming now your CH. Okay. That CH there, and this will open. Okay. You have your negative oxygen. Then you have your hydronium or H plus coming from your solvent. Okay, will attack that H plus to form your OH. Okay, so this will now be the product. This is actually a benzyl alcohol. Okay, if you remember when we name aromatic compounds, this is actually a benzyl alcohol. So from benzaldehyde, you reduce that using sodium borohydride or lithium aluminum hydride, and therefore with the presence of a solvent, then you can form benzyl alcohol. Okay, remember aldehyde to primary alcohol. So this one is a primary alcohol. Okay, aldehyde to primary alcohol. Okay, how about this one? This is a ketone. Okay, that is a ketone. You have your R there, then you have also another R there. So remember, your ketone when we reduce ketone, you will form a secondary alcohol. Then you have your lithium aluminum hydride, which is our source of the hydride nucleophile, and your water is our source for your H+. Okay, so therefore, what happens now there? Okay, your partially positive carbon will be attacked by your hydride nucleophile. This will open the double bonds in the oxygen, that becomes negative, and we will attack the H+, okay, from the solvent, and therefore this becomes your secondary. So you have your CH here, which is coming from the attack of your hydride to the carbon, and you have your OH also there. Okay, you notice that this is a secondary alcohol because that secondary carbon there, this is a secondary carbon, you have two carbons attached to that carbon. Okay, then therefore this OH now here is a secondary carbon. Okay. Okay, so for example, so you have your cyclohexanone. So I will not anymore discuss about naming for ketones and aldehydes because we have not yet discussed that. Okay, so you have your cyclohexanone. You have your carbon here. Okay, am I right? And this is a partially positive carbon. You have your lithium aluminum hydride as your source of your hydride nucleophile. Okay, your hydride nucleophile will attack that. So what happened? You have your cyclohexane. Okay, so therefore this carbon would attach by an H because of a hydride. Okay, and therefore that breaks your double bond. So your O would be attached to an OH. So this is now your product. That is actually a cyclohexanol. Okay, so that is a cyclohexanol. This is single bond. Okay, that is single bond. It's not clear, but both of that is a single bond. Okay. Next, you have your ketone. Okay, this is dimethyl ketone, or actually this is what we call the acetone. Okay, you have your source of hydride. Okay, then this will attack your partially positive carbon there. So what happened? You have your CH3. Okay, you have your carbon. Then you have your H there. That is coming from your hydride. Okay. Then that carbon in here would be attached by an OH. Okay, that would now be an OH. So this is now the product. That is actually 2-propanol. 1, 2, 3. That is 2-propanol. So from ketone to, that is actually 2-propanol, or this is acetone. Your product or reduction of that will yield to a 2-propanol. Okay, this is a secondary alcohol. Remember your ketone to secondary alcohol. You have your ketone and also a secondary alcohol. Next, you have your 1, 2, 3, 4, 5. This is pentanal. Okay, this is pentanal. You have your sodium borohydride as your source for your hydrogen. So if it is an aldehyde, then therefore the product should be a primary alcohol. Then you would expect that the product would be CH3, CH2. It's a primary alcohol. CH3, CH2, CH2. 1, 2, 3, 4, 4. Then you have your CH2. Okay, CH2OH. So that becomes a pentanol. So from pentanal, it becomes your pentanol. 1, 2, 3, 4, 5. So this becomes CH2 because your hydride there will attack that carbon, forming another CH. So that becomes CH2, and this will open the ring, not the ring, the double bonds. Then you have your hydrogen here will also will attach to your oxygen to form an OH. Okay, so that becomes a pentanol.